integration. So this is actually integration by substitution. That is the last part of substitution. So you refer to your notes, right? Now the substitution is a very special substitution. You can also call it T substitution, where T denotes tangent half x. Now why is this so special? Because when I say T is equal to tangent half x, then you look at the double angle formula or half angle formula, whatever you want to call it, double or half angle formula for tangent x. For tangent x, you know that tangent x can be expressed as 2t divided by 1 minus t squared, right? So the definition of the tangent is the opposite side of a triangle divided by the adjacent side of the triangle. So this is tangent x. Now suppose that I draw a triangle here, all right, a right angle triangle, of course, and I call this angle x. So if this is angle x, then the opposite side is 2t. The adjacent side is 1 minus t squared. Now the question is, what is this hypotenuse? So let's say now I call this hypotenuse h. Okay, I call it h. So what is the h in this case? Therefore, I can find the h by using square root of. So you have 2t in the bracket squared plus 1 minus t squared in the bracket squared. And of course, you need to expand. So when you expand, now you get the expression like this. You have 4t squared, then you have plus 1, then minus 2t squared, then plus t to the power of 4. So you simplify this. Yes?
Ines at the waiting room.
Ines and Huang Junwei. Right. So we continue. So you simplify this one, you get the form 1 plus 2t squared plus t to the power of 4. And therefore, if you express in the square, perfect square form, you have 1 plus t squared in the bracket squared. Hence, you found that the hypotenuse is in the form of 1 plus t squared. So now you found the h, and the h is 1 plus t squared. So this part is 1 plus t squared, this part. So once you have this one, okay, you can now write down sine x and cosine x in terms of t. So sine x is 2t divided by 1 plus t squared. And then cos x is given by 1 minus t squared divided by the hypotenuse, which is 1 plus t squared. And now you can see that these two formulas are actually available in MF19. Okay, so MF19 page 5. So you see sine x is equal to 2t over 1 plus t squared, and cos x is equal to 1 minus t squared over 1 plus t squared. This is the Weierstrass substitution, T substitution. All right. Okay. So now we continue. So you can quote these two. Now, other than these two, right? You see, when I have t equals to tangent half x, I am supposed to find a relationship between dt and also dx. Okay. So what is the relationship between dt and also dx? Knowing that t is equal to tangent half x, so I want to differentiate t with respect to x. Then you know that differentiating tangent half x means secant squared bracket. Then you are supposed to differentiate the bracket. So inside the bracket is half x, half x. So secant squared using the identity, differentiate half x, you get half. Then using the identity for secant squared half x, that would give you 1 plus tangent squared half x. So you have 1 plus t squared. So in other words, dx dt can be written in the form of 2 over 1 plus t squared. You have this one. And therefore, the relationship between dx and also dt is 2 over 1 plus t squared dt equals to dx. So this is the relationship. So we are going to use these expressions to solve the problem. All right. So remember how you change the x to t, how you change the sine x to terms in terms of t, how you change the cos x to terms of t. All right. Now, under what situation this is very useful? This t substitution. Okay. So I put the remark here. Useful for integral in the form. So in these two form, you need to remember particularly these two form. Okay. So what are these two form? Number one, you have the form 1 over a plus b sine x dx. Then you can use the t substitution. Or the second form is 1 over a plus b cos x dx. Okay, so you can change your sine x and cos x to 2t over 1 plus t squared or 1 minus t squared over 1 plus t squared. All right, so I'm going to show you an example. How are we going to use this? So example number, I think you can refer to (25). Okay, 25. Use the substitution t equals to tangent half x to show that the integral of the definite integral of 1 over 2 plus sine x dx equals to root 3 over 9 pi. So 25. So for question 25, I find what is this 2 plus sine x first. All right. So 2 plus sine x means 2 plus, just now I derived already. Sine x means 2t over 1 plus t squared. So 2t over 1 plus t squared. So I try to simplify this one. I will get 2 times 1 plus t squared plus 2t divided by 1 plus t squared. Factorizing the 2. So I have 2, 1 plus t squared plus t on top divided by 1 plus t squared. Right? So this is 2 plus sine x. But the integral given to us is not 1, is not 2 plus sine x. It's 1 over 2 plus sine x. Okay? That is what they gave us. So therefore, I try to find what is the reciprocal of it. So the reciprocal of 1 over 2 plus sine x, that would mean 1 plus t squared go up, then the numerator come down. So you have 2 t squared plus t plus 1, something like that. So this is the 1 over 2 plus sine x. Okay. Furthermore, because they gave us the definite integral, and you are using the t substitution, t equals to tangent half x. Therefore, when the upper limit x is equal to, what's the upper limit? Pi over 2, right? So when x is equal to pi over 2, so you can now say that t is equal to tangent pi over 4. So the answer is 1. And then the lower limit x equals to 0. So t is equal to tangent 0, which is equal to 0. All right. Now, because this is a proof question, so I will remind you to write down all the steps. All right. So therefore, now I can write down the integral. The original integral is the integral from 0 to pi over 2, 1 over 2 plus sine x dx. So now we are going to change all this into t. So 0 is replaced with 0. Pi over 2 is replaced with 1. So 1 over 2 plus sine x means 1 plus t squared over 2 times t squared plus t plus 1. Then your dx now change to 2 over 1 plus t squared dt. And what do you observe? You can observe that the 1 plus t squared cancel out with this 1 plus t squared. The 2 cancel out with the 2 nicely. Okay, therefore, the result that you're going to get is the integral of 1 over t squared plus t plus 1 dt from 0 to 1. Now, the next question is, how shall we proceed with this integral? Any idea? Can anyone suggest the method?
Complete the square.
Sorry?
Completing the square first.
Yeah, completing the square for the denominator. So if you look at the denominator, you have t squared plus t plus 1. Please do the completing square for me. Just now we stopped at who? I forgot. Oh, is it number 7? Yeah, I think it's number 7. Okay. So the student with the ID number 19047034, can you please nominate the next victim? 1 up to 24. Choose a random number. 18. Okay. All right. I give you 1 minute to do the CDS first. Okay. The student number 19043942. I repeat, 19043942. Please give me the CDS form.
T plus half square plus 3 over 4.
Okay. All right. Now you do the CDS already. Then what are you supposed to continue with? Can you please nominate the next victim? 1 to 24. Choose a random number.
8.
Number 8. Number 8 is the student with the student ID number 1906 2017. 1906 2017.
Use the arctangent.
Arctangent formula. So before you use the arctangent formula, you better express in this form. So you have 1 over t plus half squared plus, you put this in the square form, root 3 over 2. Okay, this one is 2. Root 3 over 2. Square dt. So if you use the arctangent formula, what are you supposed to get? Like 19062017.
You will get 2 over root 3 arctangent 2 over root 3 times.
Root 3 tangent inverse.
Then 2 over root 3 times t plus half.
Okay, this is what you will get. Okay, from 0 to 1. Actually, right? No, too many bracket already. Okay. Actually, the formula that our friend is using is 1 over a tangent inverse t plus half over a. Okay, where a is root 3 over 2, where a is equal to root 3 over 2. So therefore, if you have 1 over root 3 over 2, you get 2 over root 3. Okay, then this is tangent inverse. So therefore, you have 2, then t plus half divided by root 3. from 0 to 1. This is P3 formula, tangent inverse. So therefore, you expand the numerator inside the tangent inverse function. So tangent inverse, you get 2t plus 1 over root 3. Then you sub in 0 to 1. So you sub 1 first. So you have 2 over root 3 tangent inverse. So 2 times 1 plus 1, you get 3. 3 divided by root 3. Okay, 3 divided by root 3 is actually root 3, right? So it's actually root 3, right? Then minus tangent inverse. You sub 1 inside, you get 1 over root 3. So your job is to evaluate this. So you have 2 over root 3. Tangent inverse root 3 give you pi over 3 minus tangent inverse 1 over root 3 gave you pi over 6. Okay, so therefore you simplify these two, you get 2 over root 3 times pi over 6. So the answer is just pi over 3 root 3. And that's the answer. All right. So the answer is okay. Root 3 pi over 9. How come? Oh, okay. They want you to get rid of the root 3 at the bottom. So what you can do now is you multiply up and down by root 3. Okay. So therefore you have root 3 pi divided by 3 times 3. Therefore you get the answer. Root 3 over 9 pi. Done. Okay. So that's the answer for question number 25. Right. So question number 26. The integral of 1 over 3 minus cos x. So how are you supposed to start? Actually, I told you just now. When is the t substitution, or you call it the Weierstrass substitution, important? When is it useful? You can look at the two forms that I give you over here. Whenever it's in the form of 1 over a plus b sine x or 1 over a plus b cos x dx, then it becomes useful. So if you look at question number 26, okay, question number 26, I think 26 is the integral of 1 over 3 minus cos x dx, right? So you can use the substitution. So before I start, I call this one I first, all right? The integral, I call it I. So therefore, I let t be tangent half x. So therefore, you have dt dx equals to half times 1 plus t squared. So therefore, dx is equal to 2 over 1 plus t squared dt. Okay, so you have this one. And because no limit is given, therefore it's okay. Then after that, cos x is in the form of 1 minus t squared over 1 plus t squared. You can quote this result straight away because it's given in formula list MF 19. So therefore, I want to find what is 3 minus cos x. So 3 minus cos x means 3 minus 1 minus t squared over 1 plus t squared. So you try to combine them. You have 3 plus 3t squared minus 1 plus t squared over 1 plus t squared. Please be extra careful when you do this part here. This is plus, please take note. Because the negative multiplied by 1 and negative multiplied by negative here. That's why you get a plus. Be careful. That is where some people may make mistake. So you have 3 minus 1, you get 2. 3t squared plus t squared, you get plus 4t squared over 1 plus t squared. Now in this case, I can factorize the 2. I have 1 plus 2t squared over 1 plus t squared. So this is 3 minus cos x. Therefore, if I ask you to find the reciprocal of 3 minus cos x, so reciprocate the right hand side as well. So now 1 plus t squared go up, the 2 and the bracket come down. So you have 1 plus 2t squared. Okay? So therefore, the integral of 1 over 3 minus cos x dx, you can use the expression that you have simplified, which is the integral of 2 bracket 1 plus 2t squared. This is 1 plus t squared. Then the dx, you change it to 2 over 1 plus t squared dt. So 2 over 1 plus t squared dt. So you see, there are some terms cancel out. So the 2 and the 2 cancel out. 1 plus t squared and 1 plus t squared cancel out, leaving behind the term, the integral 1 over 1 plus 2t squared dt. Right? So how should we continue? When you have 1 over 1 plus 2t squared, it will be useful if you factorize the half. So when you factorize the half, you get 1 over, then you have half plus t squared dt. So in order to integrate this, you change it to the form of 1 over root 2 in the bracket squared plus t squared dt. So this is actually in the format. This is in the format of 1 over a squared plus t squared dt, which then give you 1 over a tangent inverse t over a. This is actually given in formula list MF19 in P3 MF19. So what formula am I using here? So you can refer to page 3. I think here. Okay. Not page 3, means page 4. Page 4. So you see this part. 1 over x squared plus a squared is actually 1 over a tangent inverse x over a. I'm using this. So you try to convert into the form of x squared plus a squared. X squared plus a squared. All right. So therefore, I have this 1 over a tangent inverse t over a. So now I can proceed by using the theorem. I will have 1 over 2 times 1 over a. So the a is actually 1 over root 2. That is the a. And tangent inverse. So you have t divided by 1 over root 2 plus c. So simplify this, you get 1 over root 2. 2 times 1 over root 2 means root 2 at the bottom. So you have tangent inverse. This is root 2 t plus c. However, you cannot stop here because the original integral is in the form of x. It's in terms of x. So I in terms of x means you must give your final answer in terms of x as well. So therefore, the answer is 1 over root 2. Then you have tangent inverse root 2. What is t? T is the substitution tangent half x. So you have to put this back plus c. So that is the answer for this question. 1 over root 2 tangent inverse root 2 tangent half x plus c. All right. So that is actually the end of lecture 5. So just now I said there's one question where you can do and then give me the answer by 2 o'clock later. All right. If you have any question. If you have no question, then I will end the lesson here. I will send you this file now. Okay. Then I will send you lecture 6 later when it is ready. All right. I'm still working on it.
Thank you, sir.
Thank you, sir.
Okay.
Thank you,
Okay.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.